So to have a discussion of the various issues that can come up with creating tables that support recursive relationships. One of the first things that often appears is where we have kind of a lock and block situation. In other words, you're trying to insert a record. It has to have a foreign key, but there's no data yet in the table. So often what we do is we add the foreign key relationships later on. That becomes important, especially if you're not going to allow null foreign keys. Let's build an example. I'm just sitting here between last class and this one thinking, what kind of example could we do? Kind of similar to our person table maybe, but I picture kids going on summer camp, right? You've got all these campers there. And maybe for each tent or for each lodge, if they're more wealthy campers, right, they actually have wooden structure to sleep in instead of just canvas. Okay, there's one camper who's going to be sort of the squad leader, you might say, right? So we're going to keep it really simple. We'll look at creating a table. Camper, right? And in this table, as I said, we're going to have it quite straightforward and simple. So we'll have just an ID for the camper. Maybe I'll put capital letters. As a int identity. And we'll make that the primary key in a few minutes. And as I said, I want it to be simple, so we'll just go with name. We don't worry about last names at camp. Like it's Sally or Jimmy, and if there's two Jimmys, it's Jimmy 1 and Jimmy 2, okay, in the squad, right? So we're just going to have a simple name. Varchar 30 or 50 maybe, just because
we want to do names where it's first and last?
Oh yeah, we almost always do.
No,
we have
not,
separate.
Not as separate columns, just name contains first and last.
No.
Why not?
Because if you say want to sort by last name, then you have to parse it out each time. That takes a lot of CPU cycles just to do all that extra work. Okay. So yeah, good question though, but and not null. Okay, so that's all we're going to track about them except for the foreign key, right? So the foreign key will just be really the ID of another camper, but what did we say we call that? The squad leader or just leader? We'll call them a camp leader, okay? Leader ID. And that's just an int. And then we say everybody has to have a leader. So I'll put null, not null. Okay. And then I want to add a constraint. And PK camper ID. Right? Primary. I guess I should capitalize. Primary key based on ID. And that's it for my table.
You put PF instead of PK.
Oh, did I put PF? Thank you. Okay. Oh. I'd lose marks on a test if I did that, so thanks for catching that for me.
A small reminder,
Yeah.
not null means the table has to contain one,
That's right.
but individual ones can miss them.
No, every record, these fields aren't allowed to be null.
So for leader, most people just say no, or just a false. Because there's only one leader, right?
Well, everybody has to have a leader, is what this is saying.
they
So I'm
have a
showing
leader.
the problem of doing it not null. You're thinking ahead, and that's good. This is going to be a problem, not allowing a null for the foreign key,
Okay.
right? Especially when we go to try to insert data. So hang on. So I'll create that table. That made successfully. So let's try to insert a record into here. So we'll insert into camper. And to the name, yeah, and leader ID. Sorry, my my capitals are all messed up. Values. Jimmy. Well, probably the next camper will be his leader. And then I'll just copy that. So the next one will be Penny. She broke my heart in grade 3. Okay. And Jimmy can be leader. Well, those are the values. Oh, I'm putting double quotes. Sorry, I've been programming in C# all day long. There we go. Okay, so we'll try to insert these records. Darn. Why did that work? Okay. They keep on improving this darn tool on me. I was hoping to show you the problem is how could we insert this first record when record 2 doesn't exist? Oh, I know why, because I didn't add my foreign key. Okay, so I showed you the solution. Don't add the foreign key until after you have some data in there. Because I forgot the foreign key up here. Sorry, jumping ahead of myself in the solution. Let me delete star from camper. Or just delete from camper. Empty out all the data. Okay, so now it's empty again. So let me come back up here. I'm just going to put, because I'm going to be dropping and recreating this numerous times, I'm going to drop table camper. Go just the limits and says, okay, do that first, guaranteed, before you go on to the next. Okay. So if I drop table camper, before I make it again, I can add now my other constraint, right? Because we need a foreign key constraint. FK. And that's, oops, sorry. So that's going to be on, the foreign key is leader ID, references, camper ID. Oh, foreign key. I guess I have to make my font smaller. Sorry to everybody at the back of the room. Okay. So now I'm going to drop a table, recreate it with the foreign key constraint, right? Because really we want foreign key constraints to guarantee referential integrity, that we don't have values that shouldn't be there, and so on. So I'll drop the table, recreate it. Tell you what, I'll get rid of that. Just drop camper. We'll recreate camper. There we go. So we have it with the foreign key created as well now. So now let me try my inserts. Okay, so here's the problem, right? With no data in the table, obviously I can't insert records because, okay, well, 2 doesn't exist yet, right? Even if I had 1 there, it wouldn't work, right? Because without data, there's no value existing to satisfy the foreign key constraint. So if you needed to do this kind of a setup, you would have to not add the foreign key until later, till you at least have some data in the table. Now let's change this from not null, right? I can just take out not null, and that implies that it allows null. So let me drop the table again. We'll create it, allowing nulls for the foreign key, okay? But we still do have our foreign key constraint, right? Now, can I insert my data? Aha. It still won't let me, right? And the messages are basically the same. I think they're exactly the same, okay? So even though it would allow null, okay, I'm supplying values and they don't exist yet. So that didn't really help me. So if I do want to add values, now if I was going to put null in each of these, I would be able to insert the data. But of course, I don't actually have the foreign key value. So if there really were foreign key values that were valid, and I want to insert them at this stage, right, I can't, okay? Not until there's some data in the table. Now I've got those 2 in, so that's a certain number of IDs. I've probably used up a few, so let me just check. Okay, we're on 3 and 4. So in theory, I could add just plain Jim, as long as he has a valid value here of, say, Penny is Jim's leader, right? And we'll add Betty.
If you drop the table, how come it continues creating IDs?
No, that was from the failed 2 inserts.
Oh,
Yeah,
okay.
I dropped the table, but I had 2 failed inserts, so those numbers were used up on the failed attempts.
Oh, okay.
So those worked, right, because there were existing values. The point is, it's often difficult to get data in there when it's empty if you have a foreign key constraint. So as a general rule, what we often do, and as a general practice with these recursives, is you just leave this out until you get the data inserts in place. So how do we handle that then? Let's say I left this out and I want to add it later on. Let me just Control X, cut that out. Once more, I'll drop the table. Okay. I will create the table without the foreign key, and I'm allowing nulls. Now the fact that there's no 3 and 4 won't matter, because without the foreign key constraint, it doesn't check if there's an existing camper with those IDs. So I should be able to run these. And if I select the data in there, okay, I see I successfully have data in place. So when you're first doing this type of query, what we'll often do is take the foreign key constraints out and add them afterwards. How do we do that? Well, we've never done it before, so it's a chance to learn something new. How to add a constraint after the table's been built. Anybody have a guess? We said earlier on in the course that there's, in the data definition language queries, there's 3 or 4 main keywords: create, drop, and what was the third one mentioned usually? Alter. Okay? No, we aren't going to worship at it, although it's awfully handy. Okay? But alter in the sense of alterations, right? So we can say alter table camper. I know I'm messing up, but I'm not going to take time to fix my capitalization. And what we can do is we can add constraint. And I'm going to paste back, okay, pretty much the exact same. Oh, I've got constraint twice. Okay. So I'll alter table camper, adding the constraint for the foreign key, right? Now, at this stage, will I be able to? Should I be able to? Should I be able to enforce this referential integrity, guaranteeing that there are no invalid foreign key values?
I'm gonna say yes.
You're going to say yes? Anybody say no? Remember, I'm still showing the data down here. It's a little hard to see from the back of the room.
If you have constraint, it's going to be impossible because we don't have a 4 and 5.
That's right. So right now, okay, we only have a 1 and 2. So these values, although they were allowed to be put in without the foreign key constraint, are not supported by the foreign key constraint, right? So I should get an error. Now watch me not. Hopefully I will. Okay. Conflicted with the same key table foreign key constraint. So I wasn't because I had invalid values, right? If, let me go back here, select star, right? So we need 3 and 4. So I got to add a couple more people. I have Jim, so I could go back to Jimmy. And he could have camper 1, right? Or he could have four as well. And I'll go back to Penny. And Penny, she's a leader, so it's null for her. Okay? So I'll run those inserts. That worked okay. If we look at the data now. Okay, so now everybody here, 1, 2, 3, 4, has a legitimate leader ID or it's null. Null's allowed because we allowed nulls because somebody has to be the leader with nobody above them. Well, in our scenario, we'll say that anyway. So,
can you reference, like, could you create a person, like, say, ID number 1 has their name and then, like, their leader ID is 1, so they would be the leader of themselves?
yeah,
Okay.
I think so. Let's try it in a second. Let's just try adding the foreign key constraint first. So I'll execute that. That completed successfully because we had no data that violated that constraint on the referential integrity. So I know it's kind of convoluted, but I just wanted to step you through some of the issues that come up more often, right, when you're working with recursives, because you got to have the values in place. In many, many cases, okay, using an alter table to add the constraint after the fact. That way you can get data in there first and then add the constraint afterwards. As long as your data that exists in the table doesn't violate the constraint, you'll be able to add it, right? Now, of course, there's options for everything. There's a way to actually add the constraint and say ignore existing data. I'll have to go back and fix it later and then let you add the constraint anyway, but that's a more advanced topic. For now, we'll just worry about having good data in place, but often we'll create the tables, insert the data, and then add those foreign key constraints in that order. In fact, if you have any tools that generate scripts to recreate a database, it almost always does it that way for the very reason, right? It's just safer. There's less chance of something going wrong if you add the foreign key constraint after you have data in the tables.
So can you change, can you alter the table to say now that after that's done, can you say, like, the leader ID int is null, or not null? Can we change that up?
Oh, you mean the ID?
Yeah.
Sorry, primary keys are always not null.
Okay.
So I could have said not null, but I don't need to for the ID because it's set up as the primary key. Excellent question, yeah, but primary keys never allow null values, right? So that's good question though. So we did have somebody asking, can we have somebody point to themselves as their leader? Sure we can. So right now, for example, I'll have to make up a new person anyway. just want to see what data we have. Now, will they exist in time, though, to satisfy the referential integrity constraint? I guess that's the question, right? If I'm inserting them, they'll get a new number. And if I'm guessing and using that number 5, will it work? I'm kind of skeptical. But let's try it, right? So instead of penny, we're just going to add pen with ID 5. Yeah, let us add it. So it must have satisfied that it created the ID first and then allowed us to satisfy the constraint. So 5 was 5, right? So that did work. I wasn't sure if it would either. Just in terms of inserting, because it's an auto-generated number, that's why I was skeptical. Otherwise, there's no reason why a person couldn't be their own leader, right? Unless you put, of course, you can always add additional logic if you want to enforce any kind of rule you want. Next term, when you have me, because I get everybody in term 2, we're going to learn about triggers. And with a trigger, you can do all kinds of tests and logic and say, well, you know, is this allowed or should I let this go? And if not, just roll back and say, no, I'm not going to let you insert the record after all. So it's above and beyond any constraint you can build into the table. You can add these triggers that happen in response to events like inserts, updates, and deletes, and then change the entire behavior of the operation if you want to. You get to really play powerful wizard with triggers. Okay, but that's next term. All right, so hopefully that'll help you as you set out on creating this. I highly recommend that you get your create tables. Don't worry about the foreign key constraints yet. Run the inserts that we've provided, and then go back and add the foreign key constraints for each of the relationships. Just avoids any possible errors that might come up. Question? I saw a hand. Was there a question? Oh, okay. Change your mind. No problem. All right. So once they're in place, remember how we query these, right? So I have my example here, my camper. Pretty simple example. But to do a query, right, on a recursive one-to-many relationship, basically we have this table brought in twice. Okay? So the easiest way to do that using the tool, if I design query in editor with a right click there, so I'll add my camper table more than once. Okay. So I can rearrange this however I like. I often like the one side in a one-to-many relationship on the left. I don't know, it's just old school. Okay. So this camper underscore 1 alias table really represents the leader, I can tell, right? Because the leader then is in a 1 and has many campers that they lead. Okay. So I will rename this. I could do it down here, change it from the as camper 1. I'll just zoom so you can see what I'm doing, to leader. And any changes I make here, will it automatically fix that for me? No. Well, it's offering to. Now, see, I'd have to change it here too. That's one reason why it's safer sometimes to use the properties, but okay, that'll be allowed. Incomplete. Oh, well, it's just the select clause is incomplete. Yeah, that's all right though. Okay, so with that in place, now we have the leader, we have the camper. So I could show the leader's name and the camper's name, right? Bring those down here. And camper. I'll just click OK. We'll look at the query here. So we have an inner join. Okay, camper to leader is camper is leader, I should say. Based on the primary foreign key relationship that the camper's leader ID matches the primary key of our leader, which is really just another copy of the camper table. And with that in place, I can actually get a list of all the leaders and who they lead. Okay? Not that it makes any difference, but. So Jimmy leads Betty, Penn leads Penn, Penny leads Jim, and Penny also leads Jimmy, right? Just to get them in alphabetical order makes it easier to see. So there's only one person here that leads two people, okay? Now, is there anybody that doesn't have a leader? Yep. No, there isn't. Because let's just double check that. Make that a right join. Oh, so Betty doesn't lead anybody, so that's why it shows up this way, right? I wanted a left join, not a right join, but that's okay. It's good to see. Okay. And if I make that a left join, then Penny has no leader, right? So outer joins really help you to see what's going on when you have this kind of a relationship. So, by the way, there's a third type of outer join called full join, right? With a full join, you get everything from both sides. The ones that relate the data will line up in the row. The ones that don't will just have null for the opposite values. So Penny has no leader. Betty and Jim don't lead anybody, right? And these ones are all matched up. And that's with a full outer join. So lots of flexibility in joins. Okay. All right. So I think you should be able to proceed with your CreateTable statements, run the inserts, then add the foreign key constraints as necessary for these tables. On Wednesday, we'll talk more about the many-to-many relationship, but I wanted to just talk about that first before you start writing your CreateTable statements. Any questions? Okay, you have a few minutes left. You can get started on the lab.